Hello everyone, this is B. Sai Bargo from section A of roll number 620111. My OT project was bisection method in the domain of antenna theory. Usually bisection method is a simple optimization technique that is used to find the root of a function or to find the minimum or maximum of a unimodal function. The method involves repeatedly dividing an interval into two halves and keeping the half that contains the solution. You can observe the lower limit as x1 f of x1 and the point x2 as f of x2 function. So you can observe that f of x1 here was the midpoint of, as we can say that it is a bisection point. How it was used in antenna theory. A half wavelength dipole of antenna is a common type of antenna consists of two conductive elements that are each quarter wavelength long. The total length of antenna is therefore half of the wavelength. The main aim is that the radiation pattern of the antenna is determined by its length and intervals by optimizing the length of two input intervals. So it can maximize the antenna performance at specific frequency and as well as radiation pattern. This is the algorithm for bisection method. First we have to choose an initial interval as A and B which contains the root. Now we have to compute the midpoint C, new point C as A plus B by 2 as an new interval. While evaluating the function at C, we can observe that if the C value is 0 or very close to 0, we have to stop the function and stimulate the result. If the value of C has same sign as the function value as set A equal to C or set B equal to C, we have to repeat the step until we get the value C as 0. Now we can look at an example here. X cube minus 0.165 x square plus 3.993 into 10 power minus 4 equal to 0. We have to use this equation and find the roots to find where the antennas which is transmitting or receiving having the which maximum of radiation pattern or angle. These are the conditions for bisection method. You can see that XL denotes the lower limit, XM denotes the midpoint. F of XL into F of XM. Here the root lies between XL and XM. Here the root lies between XM and XU. XU denotes upper limit. If both are equal to 0, the root is XM. If the algorithm is true, we can see the result here. For the first iteration, we can see that we assumed XL as 0.0 and upper limit as 0.1. While checking the function 0.0 and 0.11 in the given equation, we can observe that f of x lower limit was 3.93 into 10 power minus 7, that is 0.003. You can observe here f of x 0. As well as you can see the upper limit as minus 2.662 into 10 power minus 4. Minus points here. This is the upper limit, this is the lower limit. You can observe that lower limit into upper limit gets the value which is less than 0. So the root doesn't lies between this. So for iteration 1, we have taken the midpoint as the upper limit plus lower limit by 2. We got 0.055. By taking it into the consideration, we got the value which is greater than 0. So hence the root is bracketed between midpoint and upper. So the value is between 0.055 and 0.11 for the first iteration. By taking XL and XU as the new points into the consideration, we will take the iteration 2 as next roots. We have done the same operation here for the iteration 2. We got the answer which is less than 0. So the new points are XL and XU here. For iteration 3, we got the value as 0.0687. For this, the answer, the product of lower limit and midpoint we got here is less than 0. So XM and XU, the root is bracketed between them. It is between 0.055 and 0.6875. So for this, we have done up to 10 iterations to find the radiation pattern of an antenna. We can see the advantages here of for bisection method. It is always convergent. The root bracket gets halved with each iteration. Applications of bisection method. Finding roots of a function. We have to find the roots of a function to get the radiation pattern in an antenna. Optimization of unimodel. We can say that it was bisection method is an unimodel. See, by seeing the graph itself, we can say that it is an unimodel. Optimization with bounded constraints. Yeah, it was a bounded constraints. While coming to drawbacks, it was slow convergence and initial guess is close to the root. If one of the initial guess is close to the root, the convergence becomes slower. These are the applications in bisection method. Finding roots of a function, optimization of unimodel function and bounded constraints. Now we can see the code for this. For the report, we have took an example as p of theta equal to sine square theta by theta square as a function. For which we have first we have initially defined the search interval and we have to evaluate the radiation intensity, update the, and now we have to update the search interval, and now we have to repeat the process until the determined tolerance or convergence criteria has achieved. Then we will achieve the final result. These are the bisection method conditions we have seen before. For this, we have run a code in Google Colab. First, we have imported the matplotlib for graph plotting and NumPy for the calculations. Here we defined the function and we have determined the midpoint for this part is for the bisection method part, and if it is greater than 0, it will pass to A equal to C. If it is less than 0, it will be between B equal to C. The iteration will continue everywhere, which is the condition becomes true. We have given the input as user friendly, so we can give the input what we want. We have given the tolerance as 10 power minus 6 and we have given maximum iteration value 100. This is the part for the plotation. By running this, you can observe the code. These functions are for finding the maximum angle. See, for first interval, we have assumed as 0.1. 0.1, yeah. For second interval, we have, let us assume as the value as 10. 10, yeah. So we got a 16 iterations value and the radiation pattern we got was 0.002959. It was the value for the which the radiation pattern we achieved for an antenna for the given interval 0.1 and 10. The angle was 89.999924 radians. So it took 16 iterations for achieving the value. This is the radiation pattern of an antenna for transmitter and receiver for the given inputs. So finally we got the result that we have given the interval first interval as 0.1 and second interval as 10. So maximum value we got was 0.002959 and the angle was 89.99 radians and the number of iterations was 16. So it was we can given any input for which we can find the radiation pattern and as well as the angle. So we can say that bisection method was used in the domain of antenna theory. Thank you.